All right, now we're going to be talking about um, how to use multiple source files to implement a C++ program. It's customary that when you build, larger C or C++ programs, you're going to divide it into multiple files because it would just become too unwieldy to implement large programs in a single source file. Like you can't implement um, Microsoft Windows or Mac OS in a single file. Um, as a side note, I have seen some databases like SQLite implemented as a single source file with 30,000 lines of code, and I can tell you that's a really hard file to get through. So this is very uncommon to put all your source code in one file. And there are a lot of reasons you want to divide up the code into multiple files. One is for faster compiles. Actually, the smaller your file is, the quicker the compiler will compile that file. It allows efficient development because you can give one programmer one file, a different programmer another file, and they can work independently without overwriting each other's code. So that's nice. And then there's another point that's kind of subtle that you may not realize, but that definitely factors in. You can get better version control. So you might have heard of tools like Git that allow you to track your source code and track all the changes to source code and even like test and deploy your code more easily. And those programs, they track the changes made by any given programmer. And if you have relatively small files, it's a little bit easier to see what a programmer did than if you have lots of big files and you're making, and you're trying to find the subtle differences between versions of code. It's a little bit easier when the files are smaller and they're easier to read through. So kind of a common rule of thumb that you see a lot of programmers use is to put one or at most a few highly related classes together in a single file. And that way, when you want to look at some code or modify some code, you can kind of easily identify the files, the small set of files you need to go and look at. Now, why does this matter? Well, we've just been implementing lists, and now we're going to use lists to do some other things. And we don't want to keep building on to that same source code file and just making it grow and grow. What we want to be able to do is just include a header file that brings in that list definition and then allows us to reuse it in a convenient way. And so we need to transition to more of a multiple file approach. Okay, so the general approach is that you split the class declarations between a header file and a source file. So the class declaration is going to go in a header file so that it can be shared by many source files. And really a class declaration is really just a promise to a compiler to implement something. And so you can include that in multiple files without causing problems. It's like a function prototype in C. Okay, but member function definitions can only happen once in an entire program. So they can only go in a single source file because global variables and functions should only be defined one time, right? If you define the same function twice, it would be a conflicting definition. So the general strategy is, whereas, up until now, we've been writing a class kind of like this, where we put everything together. So we have class A, and then we have some member functions and member variables inside of it, and we just put all of that in our C++ file. Now what we're going to do is split it into two parts. And we're going to put class A in a declaration into a header file. So we're going to maybe call this file the name of the class.h. That's kind of a common style. You don't have to do it. There's no requirement that you do it. It's just stylistic so that programmers looking for your class can find it easily. And then inside this file a.h, we put the declaration for class A and all of the pieces for class A, but for the functions, we don't necessarily implement them. We just put declarations in the header file. And then in the C++ file, we're going to call this file a.cpp, so the name of the class followed by C++, to let us know this is a source file. We include the header file we just created, a.h, and then inside this C++ file, we provide implementations for all the functions. So we provide a constructor implementation and then an implementation for getX. Now, normally really small member functions like this, you may keep in the class declaration. It's kind of, it could go either way. Really simple functions could go either way, but a big function with a loop and more than a few lines of code, you tend to want to always put them in the C++ file, because there's a high chance you're going to want to edit those functions at some point. And if you put them in a header, then anything that depends on the header would have to eventually get recompiled. And you probably don't want to be recompiling. Anytime you make a change to your code, you don't want to have to recompile all of your code to get the program to run properly. You just want to recompile the few little parts that you have to recompile. Okay, so I'm kind of violating a common idiom, which is to put simple functions in the header file, but this is just to show you how it works. There are a few things to note here. Somehow the compiler has to locate header files that are included in order to build the code. And the compiler by default looks in several places. It's going to look in the system directories on Linux or Windows or Mac, whatever system you're running on. There'll be special system directories like /user include that are expected to hold header files. It's going to look there for a.h. It's also going to look in the current working directory. This is the directory wherever you're running the compiler. And it's going to say, oh, I see an include to a header file. Let me see if it's in this directory where I'm running right now. And it'll look for it. And then it'll also look in directories used by the C++ standard library. So, and wherever the directory is that holds IOStream and CMath and standard.io.h, it'll look there too. Now, if you wrote your own header file and it's not in any of those directories, then the compiler is not going to be able to find it. It's not going to do a search over your whole system looking for a header file. And in that case, you have to tell the compiler exactly where to look for your header file. And the way we do that with G++ is to pass in an extra flag, which is the include flag, and it's written -I. And then after that capital I, you just provide the name of the directory. I just made this up, my includes, but whatever directory you put your include file in, you need to write out that full directory path, not the name of the file, but just the full path where you can find the file. And then G++ will look in that location for any header files that it can't find in the default directories.